And there you have it. That is a box of parts that is empty, or at least relatively so. I thought about maybe I should or shouldn't do a video right now because I'm not exactly done, but here we are. So if I don't like it, I just won't post it, I guess. But this is a large part of the Baby Huey power circuit, power board already wired up. I got two of them to the same spot. So there's the other one. I just kind of wanted to walk through the circuit a little bit. I don't know, for anybody that's interested in seeing it. This right here is a big bridge rectifier. It takes two 6.3 volt windings. With a bridge rectifier, it's probably going to turn that into about 20, somewhere between 15 and 20 volts DC. Again, I didn't like the 25 volt cap that was there, so I'm waiting on that. That's cap number 7C7. If we come over here to the board, where is C7? There it is, C7. So you can see I don't have C7 yet. You can see it's listed as a 25 volt cap. So waiting on that one. That one's coming in the mail. The other thing that's missing is the bridge rectifier. So it goes in here, and it is in the mail. Maybe. Well, actually, I don't think it's shipped yet. Unfortunately, I saw where somebody called Parts Express Parts Eventually. Well, that works the same for DigiKey and Mouser and all the others. The supply chain is still just absolutely killing us right now. But that's where we live. The next thing, then, I guess, is this this was supposed to be a 6.3 volt input. It gets a voltage doubler on it, a 5 volt regulator, not a 5 volt regulator, excuse me, an adjustable regulator that's regulated to 12 volts. And I changed this up. I changed this up a bit. So this, instead of being 6.3 volts on the input, I've made it a 9 volt on the input. That way I can get closer to 20 volts out here, which is how I have it listed on the schematic. I'll see whether that actually happens or not. I'll explain why in a bit. We got a green LED that tells us that we've got that voltage on. The 12 volts is on. The 12 volts then comes up to feed a 555 timer. The 555 timer then turns on a relay, and the relay, what it does when it's off, is it actually powers up slowly all of this capacitance. So there's a thermistor in there too to slow things down, to stop inrush. But they had some capacitance here. I've got more, so I really like this. Is called a soft start circuit, so I really like the way that this soft start works. But again, I'm waiting on caps here, so C1 and C2, they are in the mail. Those will go here and here. Again, you can see they were listed as 100 volts. I've got 200, and that's because for me, well, let's come back to that in a moment. Anyway, this 555, or excuse me, the adjustable voltage regulator here gets us 12 volts out before the regulator, 20 volts. The 20 volts is drive, that's the solid state part of the circuit, of the tube amp itself. But the reason I'm pointing out the 12 volts a bit is because I've actually left myself two leads, the ground lead and a positive lead, where I can come off of this thing, not very elegantly right now, but with 12 volts. And that's because I like to have a little VU meter. I've got little VU meters set up currently on the carry amp. It's a separate little box, but I'm going to be able to build one of those into each one of my monoblocks, which is pretty cool. So this will feed a separate converter, a boost converter, up to 250 volts for the VU meter. And again, I'll probably make that so that's switchable. I can turn it on. I'll be able to adjust it. I've got some adjustment now already in the one I've built. Another thing you're probably seeing right now is this little bit of a kludge. So the guy who laid this circuit out unfortunately passed away a few years ago. Kind of surprising and sudden. He was doing a lot of cool design work. And this version of the power supply board, I have an older one, and he, for this MOSFET here, the pad that he grabbed for the circuit, for the part was reversed, drain and source. So we've had to swap the drain and source, which is effectively what's going on here. Additionally, in his original circuit, he had a lot more resistance in here. I don't know if it was for filtering or what it was for, but for me, this is a short and just 10 ohms there on the input there. Let's see, coming back, let's see. Yeah, so I've talked about the 12 volts. I've talked about the 20 volt drive. You'll see that show up. And again, this is higher as well. So in the original circuit, this was 50 volts. That's for the bias for the EL 34 tubes, an EL 84 tube, but I don't know, I guess the EL 34. I don't know about the EL 84. I didn't read as much about that one. But with the KT88, I need a bigger bias differential there. So 80 volts on the input, a voltage doubler. Again, I've increased those caps and I'll be able to come out with about 200 volts regulated here. And that's what this MOSFET does. Is this is a regulator, a nicely regulated part here. And then this R2 here, this really sets your regulation. So what voltage is this output? Because really I'll have something like 212 volts after voltage doubler and all that good stuff. And so this will be need to be regulated, so it's not really adjustable. I'm gonna have to figure it out. I've got based on the calculations, I should need about 39K in there. So I haven't ordered the 39K, but you can see if we flip the circuit over, that R2 is still not been populated. It was originally 470K in there. They're set up. You can also see R1's missing, R6 is missing, and that's because the drain and the source were swapped on that MOSFET. So the final thing then is this power supply piece for the high voltage. So we've got 330 volt AC coming in. That should be 440 volts, maybe a little bit more by the time it gets out of here. Again, a soft start relay. So it soft starts, that does a couple of things. It allows the heaters to get warmed up and start providing heat to the tubes. Some people say that's not necessary. From everything I've read, it's probably not necessary on the 12AX7 or the KT88. But it's here anyway. And again, soft starting all this capacitance, because we're going to have 220 microfarad here after the thermistor. 390, but I've actually designed and laid out and sent out already for my little circuit board this morning. So I'll actually have 390 in parallel with 470 divided by 2, whatever that is. So quite a bit of capacitance here. I have an off-board choke, so that's going to be a big Edcore 5 Henry choke here. And eventually then we'll have 440 volts, very smoothly regulated on the output. The final thing you probably noticed as I've been flipping this thing back and forth is there's a drill bit through here. And why is that? That's because what I wanted to do, this, rather than using, and I mentioned this the other day in the video, rather than using I'm trying to get my light here, rather than using the UF 4004, 4007, excuse me, rectifier diodes, I went with Schottky. These Schottky diodes are twice the amperage, higher voltage. Will I ever use it? Probably not, but they are also bigger and will live forever and are cooler. Some people like Schottky diodes, some people don't. The reverse switching delay on the Schottky is nothing, which is better than even the ultra-fast UF 4007. We have the snubber caps here in case it does decide to try to ring or something. Nothing shows that it is, so it ought to be fine. But what I want to be able to do then, because if the silver part you can see, and especially these two, if those touch, that's bad news. So what I wanted to do, and why I ran that drill bit through those, is because I will buy a piece of nylon all thread, and I'll use some nylon nuts and washers and stuff and space that out so that those will never touch. If they do, something else has gone wrong in life. So again, you can see that on the other one hiding here in the background. I've got those Those were all lined up with the drill bit to go through there. Probably see a couple other little kludgy things. This resistor, which is the soft start resistor, whatever resistor the circuit called for, they didn't have. I bought something that I thought was the power rating. It's really big, actually. It's probably more than it needs to be, but it interferes, and so I've had to snake around with some shrink tube just to make sure it never touches anything. The other big concern that I have left, well, a couple of things. I obviously don't have the adjustable voltage regulator or that MOSFET mounted yet. I don't have thermal paste and I don't have micas. I need to get those things ordered. Initially, I thought it wasn't a big deal. The rectifiers, the back plate of the voltage regulator and the back plate of the MOSFET is connected. It's ground or something like ground for many parts. If I connect right to the heat sink, out, if I connect that part right to the heat sink and I put the heat sink in here, it ought to fit. Should have fit. Should fit. It did fit earlier. Anyway, heat sink sitting in there. These little dudes are not on ground. Sometimes they are in some circuits. And so initially I was like, you know what, that's not that big of a deal. Who cares? Wow, those don't look like they fit. That's annoying. But if those are ground, then you run the risk of putting something to ground that shouldn't be grounded, because not all of these are necessarily at ground, especially this 5-volt regulator or this adjustable regulator. It wouldn't be at ground because it's off of ground with some resistance. So whatever that is could potentially be connected to ground, and you could create a circuit that you don't intend to create. So often what we do is we put a little mica plate in here so that this doesn't touch, it doesn't make a circuit. And again, that these are not connected to ground meant that I didn't have to do that. And initially I thought, no big deal. I'll just connect them without the micas. I'll get some thermal paste. But then I changed my mind. And I changed my mind because no matter what, even though these aren't connected to ground, this big piece of metal will be connected to some part of the regulator or the FET that goes in there. And what if something touches that? Poop. So I want to reduce that risk. So if I put a mica on there, I reduce the risk of making another shock hazard. So that's what I'm waiting on. That's another part. I need to order the micas. I need to order my thermal paste. I haven't done that. Let's see. Big O, what is that? That's C10 here. That's supposed to be the 200, originally 47 microfarad, but now 220 microfarad. That is this dog here. And what's going to happen there is I will zip tie that down. I'll put a double-sided tape zip lock or zip tie pad down there, strappy thing down there, and then I'll just wire that with wire over to where it needs to go. The other thing I'm probably going to do, because I've got the off-circuit daughter board that's going to hold all these caps, well, I'll have one that looks like that and another one that looks like this, but with another one of those there, which I've got on order. That daughter board, what I'm going to do is I'm going to take some of these Phoenix connectors. I think they sell individuals, and I'm actually going to attach them to the bottom. And then I'll be able to come out from the Phoenix connector over to my daughter board, which has a Phoenix connector on it, and I'll be able to wire all that up. So again, that's already on order. Pretty cool. That's from JCL PCB. $2 boards, 5 boards for $2, $50 shipping. So those will be here in a couple weeks. Hopefully these are supposed to ship this month. We'll see. This month, next month, whatever. Yeah, so like I said, this is going to take quite a while before I'm finished with this. This was a couple days, well, a few hours of soldering, maybe a day's worth of soldering, not laying things out, but setting things out, straightening out leads and all that. So this is kind of a long project.